Hello, I'm the other teacher of this class. My name's Brian Rasnow. I've been teaching at CI for about 13 years. I've taught classes in about 10 different departments, but mostly upper division physics and a UNIV course. Before coming here, I was a principal scientist at Amgen. My group was called Research and Automation Technologies. We scouted for technologies in other fields that we might hijack to help us discover human therapeutics. And I was also a go-to person to help other scientists automate their laboratory processes. Prior to that, I spent 10 years studying biophysics and neuroethology at Caltech. Question I did my thesis and postdoc on was how weakly electric fish perceive the world using their electric sense. And in the middle of my thesis work, I literally bought the farm and moved to Costa Rica to explore how to change a old and worn out cow farm into rainforest and more sustainable land uses. I've also co-founded a microscope company. Three of our microscopes are flying on the International Space Station right now, and I wear a bunch of other hats. Some of the research projects that I've undertaken at CI have been put on hold due to the pandemic, um, but I'll talk about a few of them here that maybe we could restart this semester if there's interest. It will be a challenge without contact. Um, First one is on solar um, cooking and really rethinking how food is cooked. A little more about that on the next slide. Still doing work or hoping to get back to doing work on electroreception. We're doing data analysis of experiments we did just before the pandemic. And, and then there's some other issues on microscopy. If there's anyone interested in studying groundwater, I've automated the monitoring of several deep water tube wells on the ranch with Arduinos and Raspberry Pi in order to understand whether we're sustainably using our well water or not. And then I also have an interest in exploring management of chaparral um, to see whether it would be appropriate to bury some of it to both reduce risk of fire and put this carbon out of atmospheric circulation. A little more on the solar cooking idea. Um, we as we seek to reduce energy usage, when it comes to heating and cooling, we can change the way we dress, but it really isn't a choice whether we cook our rice and beans or not. And a lot of people are still cooking using some very, very ancient technologies. And so, uh, one of the things we were building before we went virtual was a hybrid solar thermal photovoltaic oven that might be able to get to high enough temperatures to cook pizza. That's a noble goal. And but that's on hold. Um, right now, we are analyzing data that we collected from a weakly electric fish that we mapped just before the pandemic shut us down. And this data analysis, numerical methods in MATLAB. This is a poster, a SAGE poster that we put together a couple of years back on calibration of the apparatus. And this was all done with simulated electric fish data. Over here is an example of actual data from an elephant nose fish. The colors indicate the voltage, and what you're seeing is microseconds of time. This fish generates a very brief electric discharge, and poof, it is over. The microscope project is uh, basically summarized here. We radically change the hardware of what a fluorescence microscope might look like. This product fits in a lunchbox, but it's still pretty much running the user interface or the user experience, if you like, is not that different from what a user would do on a conventional microscope. And I think we're not taking advantage of seeing this device from the paradigm that it's a high throughput data acquisition machine, and much of that data we just throw out. We're taking 30 images a second, and again, most of that is just put on the screen for a split second and then thrown out. We can do a lot better. So that's something I'm eager to explore. This is my workbench at home where I talk to electrons. And this is one of my favorite spots in Costa Rica where I talk to nature and listen. One of my projects on the ranch is to maintain a 150-foot tower. So, fun question. How long does it take a physicist to change 2 light bulbs? Some of my past life, I started at Pierce College and then moved to Cal Poly as an electronic engineering student as a junior. Lasted about 3 weeks and then switched to physics. Didn't go back to engineering until about 10 years ago when I did a 4-week program at MIT. And this was a result of that. I invented this funky bicycle. If you think one wheel is up and one wheel is down is weird. Um, this was displayed at the Smithsonian Institute Cooper Hewitt Museum of Invention or something to that effect. This is a pretty revolutionary way to thresh pearl millet, and it was one of the better achievements. Education philosophy. Science, I think, is hard. It's hard for all of us. Some more than others, but it's hard. It's not a natural way to use our brain in the same way that gymnastics or ballet is not a very natural way for us to move our bodies. But with practice, we can learn to do it and do it well. And by doing so, it gives us much richer perspectives and appreciation of the world. You're going to learn most from yourself. You'll learn next most from each other and least from me. I see my role in this class as posing questions, as challenging you to do things that, if it weren't for this class, you might not contemplate doing on your own. Um, we, as teachers, we study a lot about theory, and I feel that some of this stuff, some of this material could really help students as well. Um, uh, for better or worse, we try to be better teachers, but many of us, I feel, and I look back at my own history, really didn't try to be the world's best student or as good a student as we might have been. And so I encourage you to actually look at your job of being a student as something that you might address in a formal way, just as a if you want to do ballet or sports or play a musical instrument, formal instruction, formal processes can help you be better and more effective at doing at achieving your goals. So Bloom was one of these psychologists that basically busted up the cognitive or thinking domain into these pieces, and Perry was another, I believe, psychologist who looked at different stages of development as to how we go from one level to another. Um, Kratwall, yet another one, looked at the affective domain of psychology. This is how we feel. And feelings affect how well we learn. So that is important. Not only feelings, but other things that are important to our learning are also our state of rest and stress and nutrition. And so all of those are components in being a successful student. And hopefully you'll pursue some of this formally. Well, I guess if we're into philosophy, some of my grading philosophy, yeah, that's me on the farm. Sometimes I do grading with some pretty old machines. Just got a new bulldozer this year or last year, so that will help me bury some of your papers. Uh, but we'll go into more of that later. It's a pleasure to meet all of you, and looking forward to learning from this class. Every time I teach a course on energy, I learn a lot, and I hope that you will too. Thanks.